Hello दोस्तों, welcome to KP Academy, and in this video we will solve some numericals from GATE exam, especially on topic first law of thermodynamics. So let's start. The question: a polytropic process carried out from an initial pressure of 110 kilopascal and volume of 5 meter cube to a final volume of 2.5 meter cube. The polytropic index is given by n equal to 1.2. The absolute value of work done during the process is. So this was the question from GATE 2022 for 1 marks. So let's take a look on this numerical, how to solve it. Right. So first of all, what is given here in the numerical, it is polytropic process and initial temperature and initial pressure and volume is given, right? So we'll note down the given data first. So given the P1 value, that is pressure, initial pressure is 110 kilopascal and the initial volume is 5 meter cube. The final volume is also given, that is 2.5 meter cube. So we can say it V2, that is 2.5 meter cube. So it's nearly half volume. Okay. Then polytropic index is given, n equal to 1.2, right? Now it is polytropic process and we know that polytropic process behaves with the equation PV raised to n equal to constant, right? So this is for the relation that we have for the polytropic process, right? So let's say the process is taking from 1 to 2, right? So process is 1 to 2. So for 1 to 2 process, that is polytropic process, we can write for this process, right? So that is P1 V1 raised to n equal to P2 V2 raised to n, right? Now in this equation n is equal to 1.2. Right, so we can write for that, that is P1 equal to raised to 1.2 equal to P2 V2 raised to 1.2. Now in this equation we know P1 value, we know V1 and V2. The only unknown is here is P2, right? So we can write for P2. So the P2 is equal to, what is that? Pressure P1. So that is equal to 110. So we can write it directly 110, right? Into V1 square. So V1 is 5. So 5 raised to 1.2. Now this V2 is there. In multiplication it will go downward, right? In the denominator. So V2 value is how much? 2.5. So 2.5 raised to 1.2. So if you solve this equation, we get the value of P2 as 252.7 kilopascal, right? 252.7 kilopascal, that is the P2 value, the pressure after the process, right? But we know in this equation we have to find out the work done, right? So for polytropic process, we have the equation for work done as P1 V1 minus P2 V2 divided by n minus 1. So that is what equation we have for work done during the polytropic process, right? Now we know all the values, we just have to put all the values. So P1 is 110 multiplied by V1 is 5 minus P2 is 252, just we have calculated that, multiplication V2 is 2.5, right, divided by n minus 1. So n value is 1.2, 1.2 minus 1. So if we solve this, we will get the equation the value of the work done as minus 408.92 kilojoule, right? So we get the work done during the polytropic process as minus 408.92 kilojoule. Means what? The work done is done on the gas. Whatever the gas is following the polytropic process, so on that gas the work is done, right? So that's why we can write the work done value is 408.92, but work done is on the gas. right? Not by the gas, it is on the gas. So we can write comment like this because the value was negative, right? So this way we can solve the numerical. Next question. This is from the 2021 GATE exam for 1 mark again. The question is, a rigid insulated tank is initially evacuated. There is no mass present over there, right? Initially in the tank. It is connected through a valve to a supply line that carries air at a constant pressure and temperature of 250 kilopascal and 400 Kelvin respectively. Now the valve is opened and air is allowed to flow into the tank until the pressure inside the tank reaches to 250 kilopascal, at which point of the valve is closed. Assume that the air behaves as a perfect gas with the gas properties, constant properties. The properties are given. Now final temperature of the air inside the tank is 1 decimal place. So we have to find out the temperature of the air inside the tank, that is final temperature inside the tank, right? That we have to calculate, right? The scenario that is given over here, I will draw the figure for that, right? What is figure given here? There is a one tank, there is a pipeline actually, right? So this is, let us say, pipeline, and there is a one tank, okay? So this is, let us say, the tank we have, right? And it is insulated, so we can say it is insulated, right? There is no heat transfer, as it is insulated, there is no work transfer, right? Here also, right? So there is a wall over here, right? Next, air is passing through this side, so this is the air, and it is behaving like a perfect gas, right? Let's say the temperature of that air is Ti, okay? So that is given in the numerical itself, right? Now there is no heat transfer, that's why we can say the heat transfer is 0. So Q is equal to 0, right? Now what is given in the numerical? Pi is given, right? Initial condition, Pi is 250 kilopascal, right? Ti, that is initial temperature, Ti is 400 Kelvin, okay? 400 Kelvin is given, right? Now as it is a air, we can have the gamma value also 1.4, that we know value, right? Now the scenario is the air is passing through this side and initially the tank is evacuated, that means there is no mass present in it, right? So now suddenly when the valve is opened, the air will go inside. So initially there is no mass present, so air will go inside and then the tank will be filled out, right? So at the time when the valve is closed, at the final condition, that is temperature, we have to find out when valve get closed, right? So that is what the scenario that we have, right? So now if we apply first law, if we apply mass conservation and energy conservation equation to this process, we can easily solve this problem, okay? So applying conservation, principle of conservation of mass, right? So applying principle of conservation of mass, right? Applying principle of conservation of mass, right? Considering the gas present inside the tank as a system, right? We have change in mass of the system, or we can say the gas, equal to mass that is entry minus mass that comes out, right, from the tank, isn't it? So that's what we have, right? Now mass of the system, we can write is m2 minus m1, isn't it? So m2 minus m1, okay? m2 is what? Final mass, and m1 is initial mass, right? Mass entry m in, okay, and there is m out. Now in this case, initially the tank was evacuated, so this m1 becomes 0 because as it is evacuated, there is no mass present inside the tank, right? And as valve is getting closed, then m out is also 0 because air is not passing out of the tank, isn't it? So we can write directly from this equation, that is m2 is equal to m in. m2 is equal to m in. हम लोगों को ये मिला कि m2 ही फाइनल मास जो है जो अंदर आ चुका है वो, दैट इज व्हाट वी गॉट नाउ. लेट अस से दिस इज इक्वेशन नंबर 1. So this is what we have conservation of mass, right? Now applying the conservation of energy principle, right? So applying conservation of energy principle. Conservation of energy principle, right? Applying conservation of energy principle. So what we have? We have, again I will write the equation, m2 E out, energy out, right, minus m1 energy in. Okay. Next, Q in अगर हीट ट्रांसफर हो रहा है तो, right, then W in वर्क डन अगर हो रहा है तो, right, plus some flow energy, right. So m into theta minus again heat transfer out plus W out plus summation of out m theta. So that's what we have as a generalized equation for the energy, conservation of energy principle, right? But now in this case, as the tank is evacuated, we do not have any heat transfer. So दोनों क्या हो जाएंगे, जीरो हो जाएंगे, right? Also we do not have any work transfer, so this will also become zero. So work transfer is also zero, right? Now what is this E and what is this theta in this case, right? I'll show it. So in the previous equation, from the previous equation we can write m2 E out, right, minus m1 E in equal to summation of m theta minus summation of m theta. Okay, so that's what we have. Now what is this E over here? E is the non-flowing fluid, right? Energy for non-flowing fluid, right? So what is that? E is equal to non-flowing fluid matlab inside the system, right? So it is equal to U, that is internal energy, plus kinetic energy plus potential energy for non-flowing fluid inside the tank, right? Inside the tank, whatever the fluid is there, in this case we have air, so for that we have this E, that is internal energy, kinetic energy of that fluid and potential energy of that fluid, right? Now in this case we are ignoring the kinetic energy and potential energy, so this becomes zero, this also become zero. Now what is theta? Theta is for flowing fluid, जो भी एंट्री हो रहा है टैंक के अंदर और बाहर जो जा रहा है, that is for the flowing fluid, right? So for that we have theta, right? So what is that? H plus kinetic energy and again potential energy. So H is the enthalpy of that flowing fluid, kinetic energy of that flowing fluid and potential energy of that flowing fluid. Okay, so that is what the theta we have, right? But again in this case we have to ignore the kinetic energy and potential energy for the flowing fluid. So this becomes zero. So this is for flowing fluid and this is for non-flowing fluid, matlab inside the tank. Okay, right? So now if we got this value, we can rewrite the equation, initial equation, right? So what is that? m2, now E2 is there, so from the E2 only we have U2 now, so it is U2 minus m1 and here we have U1, isn't it? So U1 equal to summation of mi hi, because theta में क्या बन जाएगा, खाली h बन जाएगा, right? So mi hi minus mo, or we can say E, right? Or we can say out, isn't it? Out h out. Okay, so that is what the scenario we have, right? Now as the fluid is not coming out of the tank, so this becomes 0, right? Mass is not coming out of the tank, that's why m becomes 0, isn't it? Now another case, यहाँ पे क्या हो जाएगा फाइनल इक्वेशन? फिर mi will become m2 u2 minus m1 u1. तो ये बन जाएगा फाइनल इक्वेशन. So this will become the final equation. But the thing here is m1 is equal to 0, right? What is that? m1 is equal to 0. Why? Reason is the tank initially was empty, right? So m1 is empty. m1 is 0, right? The reason मैं लिखता हूँ यहाँ पे, tank is initially empty, isn't it? So that's why m1 is 0, right? तो अगर m1 0 है, so this becomes 0, right? तो क्या बन जाएगा फाइनल इक्वेशन? mi hi equal to m2 u2, right? m2 u2. Now in previous slide we have discussed that this m2 is equal to m in, right? So we can write here this mi and m2 is same, right? mi and m2 is same. So finally we have, what is that? hi equal to u2. hi equal to u2. Now in temperature relation, hi can be written as Cp into T, because enthalpy is a function of temperature, right? So we can write enthalpy as Cp into Ti. Okay, that is initial temperature, isn't it? Equal to, for U2 now we have Cv, so Cv into T2. Okay, right? We have this equation, Cp into Ti equal to Cv into T2, right? Now what we have to find out here? We have to find out T2, isn't it? So T2 will become T2 equal to Cp by Cv into Ti. Now Cp by Cv is what? Gamma, isn't it? So T2 equal to gamma into Ti. Now what is gamma here? We have gamma equal to 1.4, right? As it is air, so we can write 1.4 into Ti. Ti is what? The temperature of the air, right? Initial temperature of the air, right? So what was that? It was 400 Kelvin, isn't it? So this becomes equal to 560 Kelvin. So final temperature inside the tank, right? It is 560 Kelvin. It's very simple. Applying the first law of thermodynamics to the tank, and we get the value of final temperature inside the tank, right? Next question. This is from again from 2022 GATE exam, right? It is again for 1 mark, right? What is given? Consider 1 kg of an ideal gas at 1 bar and 300 Kelvin contained in a rigid and perfectly insulated container. The specific heat of the gas at constant volume is Cv, that is 750 joule per kg Kelvin. A stirrer performs 2 to 5 kilojoule of work on the gas. Assume that the container does not participate in the thermodynamic interaction. The final pressure of gas will be in bar. So we have to calculate this first, right? So what is given? We have given mass of the gas present inside the container, right? So we can write m1, it is 1 kg, right? We have initial pressure P1, that is 1 bar. So we can convert it into kilopascal, right? So 1 bar is equal to, we can say 100 kilopascal, right? So temperature T1 is also given 300 Kelvin. Okay. Cv of the gas is given, Cv 750 joule per kg Kelvin. तो उसको हम लोग लिख सकते हैं किलो जूल में, राइट? तो Cv कैन बी रिटन एज 0.750 किलो जूल पर kg Kelvin. ओके, नेक्स्ट वर्क डन किया है. So work is done by the stirrer, right? So we can say W in, right? So it is 225 kilojoule. As it is done on the gas, we can write it as minus 225 kilojoule. Okay, W, right? So that is what W here. And there is no heat transfer, so Q is 0, right? Q is 0. There is no heat transfer given, is it? Because it is insulated tank. So अगर insulated है तो Q becomes 0. Heat transfer नहीं है. It is an adiabatic process. Okay. Now, in this case, we can apply the first law of thermodynamics now. So applying first law of thermodynamics. So applying first law of thermodynamics. I should write full. Okay. So it is applying first law of thermodynamics. So what is first law of thermodynamics? Q equal to delta U plus W. It is very simple. Q equal to delta U plus W for closed system, isn't it? So Q equal to delta U plus W. Now in this case Q is 0. So this equation can be written as 0 equal to delta U. अभी delta U क्या हो जाएगा? M CV delta T, right? So M CV delta T plus W, isn't it? अब ये लिखेंगे उसको फिर से 0 equal to M CV delta T T2 minus T1, and now ये जो work done है, work is done on the gas, so we can write is minus we can say W, right? Minus W. अभी वैल्यूज को पुट करेंगे, so W इधर ये साइड आ जाएगा तो पॉजिटिव बन जाएगा, so it becomes now 225. So 225, right? वैल्यू दिया है कि नहीं? So 225 equal to मास क्या है 1 kg मल्टीप्लाइड बाय CV क्या है 0.75, so 0.750 मल्टीप्लाइड बाय T2 minus initial temperature is how much 300 Kelvin, so 300 Kelvin. So here in this case only unknown is T2, तो अगर आप सॉल्व करोगे so T2 मिल जाएगा आपको near about how much 600 Kelvin. So you will get the value of temperature as 600 Kelvin. But हम लोगों को निकालना क्या है? We have to find out final pressure of the gas. That is in bar, है कि नहीं? So final pressure of the gas. Now see the tank is rigid, है कि नहीं? The tank is rigid. So for rigid tank we can write the volume is constant. For rigid tank volume is constant, isn't it? So volume is constant, and inside the tank whatever the gas is, it is what? Ideal gas, right? So for ideal gas we have equation PV equal to mRT. Now in this case volume is constant, M is constant, that is 1 kg, right? That means we can have the relation between pressure and temperature. What is that? The pressure is directly proportional to temperature. So for the process that is happening over here, right, we can write equation like this. What is that? P2 by P1 equal to T2 by T1, right? Now we have to calculate the final pressure. That's why P2 equal to, directly we can write P1 into T2 upon T1, isn't it? So P1 is 1 bar, so 1 bar into T2 is how much? 600, right? Divided by the temperature is initial temperature, that is 300, right? So in this case we get the value of pressure as 2 bar. Okay, so this way we can solve the problem. There will be more numericals on the GATE exam in upcoming videos, so kindly subscribe the video and press the bell icon for notification. Thank you so much.